So 2.9 is all about translating absolute value functions. And what we're trying to figure out is there's a rule for translating them. Now, we can transform them following the same rules that we use for lines, but it's this translation that we kind of want to focus in on. Okay, we want to focus in on how to translate them, because that's a little bit different. Everything else kind of follows the same as what we've been doing. So we'll practice that, but it's not new. This translation stuff is new, and so we need a rule for how we do it, and then we need to talk a little bit about how we use it. Okay? In order to do this, I want to look at 5 graphs. Of course, they don't all show up. Let's try this a different way. So I want to be able to look at 5 graphs up here and talk about them. Now, they're very, very similar. The first one is the absolute value of x minus 5. The second one is the absolute value of x plus 5. The third one is the absolute value of x plus 5. And the fourth one is the absolute value of the quantity x minus 5. Okay? We're going to compare all of these to the parent function for absolute value. Y is the absolute value of x. Boring function, but this way we can decide how things are changing. Okay, so we're going to graph each one and decide what it means and come up with a plan as to how this works. Here we go. Okay, so to do this, we're going to use the calculator out of the book. And up here, and I did it backwards, so let me just change these real quick. I have them plugged in the way that you would see them, or the way they are written over in kind of our slide. Except for I had to use the letters ABS. And when you do graphing on your 84, or whatever graphing calculator you have, you will use ABS as well. That lets you do the absolute value function. Okay? I already have the parent function up here. And this function was graphed because if you think about it, the absolute value of when x is 1, it's 1. When x is negative 1, it's 1. When it's 2, it's 2. When it's negative 2, it's 2. And so that's how we got all these little points on here. Okay, so that's our parent function. Now I'm going to turn these on and off, and we're going to talk about how the graph moved. Okay, so I'm going to turn on the first one, absolute value of x, take away 5. Graph it. Okay, that first one right there. When we look at this one, the red graph has moved us down 5. Okay? Let's turn that one off. Turn the next one on. If we look at this one, when we did the absolute value of x and then plus 5, it moved us up 5. And that kind of makes sense, because absolute value of x, that's the entire function. We haven't changed the input, we're just changing the function as a whole. Okay? Now let's look what happens when we move that 5 into the absolute value equation. So now I'm going to graph the absolute value of x plus 5. Notice my x plus 5 is in these parentheses. Okay, same thing down below. It's in the parentheses. Graph this one. Ooh, x plus 5 moved us left. It moved us to negative 5. So the x plus 5 here, this moved us left 5. Which is interesting because we have to almost think of it as x minus negative 5 to get that plus. If we want to talk about that negative 5. Okay, we can probably already predict what's going to happen in the last one, but let's just take a little look at it real quick anyway. Turn on that last one. Sorry that it's yellow, might be tough to see, but we can see that we've moved right 5. We've moved to the right 5. Okay? So there's definitely kind of a pattern that we're starting to see as to where the 5 goes and the plus or the minus. We can formulate that or put it into an easier to read kind of general format like so. Absolute value of x minus h plus k. Now that h and k should look familiar. H, k have 2 meanings. First of all, h can stand for the units moved right or the units moved left. Now remember, when this would be positive, this would be negative. Okay? K can stand for the units translated up or down. positive or negative. Great, so up or down, positive or negative, right or left for h and k. However, if you think about the way the graph of absolute value looks, hk has another meaning. H and k also represent the ordered pair of the vertex. So let's say our vertex is 5, -2. Well then if it's 5, -2, that means h is 5, k is -2. And the equation for our absolute value would be x minus 5 plus -2. Okay? And so that's what we're going to practice. We're going to practice translating absolute value equations so that their vertex lives at a particular point. 4 of them for you to try. Translate the function. Translate the absolute value of x. That's the function we're talking about here. So that the vertex is at the following point. Now I'll show you the first one, you try the next ones. So the function is absolute value of x minus h, and then we add k. So in this first one, h is -4, k is -5. So it's the absolute value of x minus h. H is -4 plus k. K is -5. Now that's a terrible way to write this. So we can clean it up a little bit. Minus a negative becomes +4, and then plus -5 is just -5. If we were to plug that in and graph it, we would have an absolute value equation whose vertex was at -4, 5. Excuse me, -4, -5. Okay? You try the next 3. Make it happen. Substitute it and figure out what h is, figure out what k is. Ready, go? Okay, let's check and see how you did in this first one. Got things moving, that's not good. Don't want anything moving on us. Okay. F of x equals the absolute value of x minus h. H here is 1. Plus k. K here is 6. Absolute value of the quantity x minus 1 plus 6. F of x equals the absolute value of x minus h is 8. X minus 8 plus k. K is -5. Okay? So we are translating everything based on this information from the ordered pair. Okay? And of course we could clean this one up a little bit and change this to a -5. Okay? And then in this last one, f of x equals x minus -1 plus -7. What's x? What's y? h, k. Equals the absolute value of x plus 1 minus 7. Check it. How did you do? How did you do translating? Now we can also go back and think about this. This means we've moved the graph left 4 and down 5. Right 1 and up 6. And when we do that, we are moving the vertex to those no ordered pairs. And that's kind of how the translation wraps up into this equation of moving the vertex. Okay? That's what we're going to be practicing. I know there's a question like this on your Chapter 2 test. So make sure you've got this. I want you to have it. Okay? We'll practice it. You'll be great. It'll be wonderful. Make sure you identify the vertex, substitute in. You can do it. It'll be awesome.